Introduction to the nervous system. Start with the functions of the nervous system. Our nervous system has 4 functions. Sensory input, in which it receives all the sensory information from all over the body, inside the body, outside the body. Integration, which is perceiving and evaluating the sensory information, like what is it? Motor output, which is going to be the response to the sensory information, and making and storing memory. So just to review the 4 functions of the nervous system. So sensory input. So your nervous system is going to receive all this sensory information, and then it's going to integrate this. Like, what is it? It's going to think about it. It's perceive and evaluate. Okay, so it's coming from the tip of the finger. It is a burning sensation. Finger is burning. And then the motor output, which is move the finger. So that is going to be response to the stimulus, to the sensory information. So the motor response. So the finger is on fire, it's burning, you're touching a hot frying pan, and so the motor output would be move the finger. And then you're going to, the brain, the nervous system is going to make and store the memory so that you can learn that frying pans are hot and they burn your finger. So you might remember that, so maybe next time you won't touch the frying pan. You're like, oh, that's hot, I'm not going to touch it. Maybe get a hot pad. So making and storing memory allows for learned behavior. So those are the 4 functions of the nervous system. The neurons are the functional cells. They're the cells in the nervous system that do the 4 functions of the nervous system. They're the main cell. But you also have your glial cells or your neuroglia in and around the neurons. So while this is the neuron, the cell that is wrapped around this cell here and this cell here is wrapped around the neuron are the glial. It's a glial cell or a neuroglia, and they're just kind of helping and supporting the neurons. And the neuron is a huge cell. It's this big, long, massive. It's a huge, humongous cell. Okay, it has the dendrites, which are these structures, and they are the ones that are receiving the sensory information. The soma, or the cell body. The soma is where the nucleus is located. That is the cell body, and then the axon, which they took this axon, they kind of like cut it, and they put the rest of the axon here. So instead of being a long model, it would be a short model. But anyway, this is the entire cell is a neuron. These cells here that are wrapping around and supporting the neuron are the glial cells or neuroglia. These structures here are the dendrites. There are multiple dendrites that are receiving the sensory information. The soma, which would perceive and evaluate and integrate this information. What is this information? And then the axon. The axon is where will terminate. There will be an axon terminate. Axon terminal terminates on a muscle cell to bring about the motor response, the motor output. Okay, now we have some anatomy of the brain. All of this pink wrinkly part here is the cerebrum, and then this darker brain part is the cerebellum. And the cerebellum is important for muscle memory. So this is when you learn to ride a bike, or you develop your golf swing, or when you learn to hit a baseball. This athletic abilities, this muscle memory is learned and stored in the cerebellum. So the cerebellum is for like athletic ability, hand-eye coordination, not memory, but muscle memory. Okay, so if I ask you, what is the function of the cerebellum, a lot of people just say memory. That's totally wrong. Okay, muscle memory. Okay, make sure you do know that. Now, down the middle of the brain here, there is this groove, kind of like separates your right from the left. This would be the right from the left, and there's the great longitudinal fissure. So what is a groove? Down the center of your cerebrum, the great longitudinal fissure. So this is the front of the cerebrum. This is the back or posterior view of the cerebrum, cerebellum down here. Now, if we could perform a cross-section of this brain and look at the inside, you will see this gray matter on the outer edge. And there's gray matter and there's white matter. And the gray matter on the outer edge is the cerebral cortex. And that is where, in the cerebral cortex, is where you're actually consciously aware, thinking. Back over here in the cerebral cortex on the outer edge of the brain, that's where you're like consciously aware, thinking. Are you going to move your finger? Are you going to let the finger burn? You know, you're consciously aware and your thoughts. Now this is another type of section. What type of section is this? So we've cut the brain in such a way that you can see this, it's divided into anterior and posterior parts. So what type of section is this? You're separating it into anterior and posterior parts. Just repetition is the key to learning. So I have to like repeat it over and over and over, and we need to also apply what we have learned. So the very first lecture, terminology, we talked about these different types of sections, and this one is a coronal or frontal section, and the gray matter on the outer edge is going to be your cerebral cortex. Okay, so the lobes. We have the frontal lobe, all this in front, parietal lobe, this parietal parts of the regions there, occipital lobe, and then temporal lobe. Temporal lobe is like right over here, the side of your ear. Temporal lobe right here, right here, right here. I want you to know a little bit about the frontal lobe and the occipital lobe. So the frontal lobe, if all of this here, all of this is frontal lobe. If you could like draw a line right here, then we have what's called your prefrontal lobe. So this little part in the very front. Our prefrontal lobe is more well developed than all the other brains of all the other mammals. And what it allows us to do is to plan ahead, to know the consequences of our actions. And so you can think 5 years ahead, 5-year plan, 10-year plan. You can think, okay, if I do this, then this, you know, one day I could be, you know, after 12 years of going to school, 15 years of going to school, one day I'll be a doctor, maybe one day, you know. So to be able to plan ahead and know the consequences of your action. So prefrontal lobe, it also is going to be responsible for like worrying, because you can know, oh my goodness, like, you know, they could get in a car accident. You could start to worry here. It's in the prefrontal lobe. Also, they say your personality is located in the prefrontal lobe as well. Now, the occipital lobe Back here is where you have your visual cortex. So all the information from the eyes is sent to the occipital lobe, and then it is interpreted back there. Like, what is it that you're looking at? So you know what you are looking at. And if you were to hit the back of your head, you know, if you fall back and hit the back of your head, you might actually see stars, like in the cartoons where, you know, the roadrunner is like, actually the coyote. That can actually happen if you kind of bruise the occipital lobe, because that is your visual cortex. Okay, I'm gonna have you review this parts of the brain. What is the name of this groove down the center of the brain? A. What is the name of all this pink part here? And then what is the name of this brain part? Y. Okay, next we're have performed the type of section right down the middle of the brain that's going to separate it into right and left halves. What type of section separates your brain into right and left halves? Especially if it's like right down the middle. So that's going to be the mid-sagittal section. So we perform that mid-sagittal section right down that great longitudinal fissure, and we can see these internal parts of the brain. So all of this right here, it looks like a 19, 20, 22. All of this right here is the thalamus. And let me tell you what the thalamus does. The thalamus is the bouncer. Okay, it is receiving all this sensory information from all over the body, and it's going to decide who gets to go up to the cerebral cortex to make it into your consciousness, so that you're consciously aware of this sensory information. So the thalamus is actually ignoring thousands of sensory information. You're receiving sensory information that you have this heavy earrings dangling from your earlobes. You're receiving sensory information that you have a watch on your wrist. You're receiving sensory information that you have a sock on your foot. But most of the time, that information is just being ignored by the thalamus, and it is not sent to the cerebral cortex to be in your conscious awareness. But now that I have mentioned those things, you probably do actually feel the weight of your earring, and you actually feel the watch on your wrist, and you feel the sock on your foot, because I mentioned it, and the thalamus says, oh, this is important, and sends it up. So just know that you do receive this overwhelming amounts of information all the time, but you're not always consciously aware of that. The thalamus does not send it up to the cerebral cortex. The hypothalamus, which is just below the thalamus, so this would be number 21 right here, all of this right here. The hypothalamus is responsible for homeostasis. Okay, it plays a huge role. It is the processing center. It knows what all the set points are supposed to be, and so what is the homeostasis supposed to be at. And if it is not within the range, then the hypothalamus is going to communicate to both the endocrine system and the nervous system that, hey, you know, it's not, we got to do something about it to get it back to this range that is considered normal. So the hypothalamus plays a huge role in homeostasis. And it is a liaison between the nervous system and the endocrine system. Like, it communicates with both. So hypothalamus actually belongs to both the endocrine system and the nervous system, because it communicates with the two and it connects those two systems. And there are centers in the hypothalamus, like the appetite center, the satiety center. You have like your sex drive is in the hypothalamus. The mind over matter phenomenon is in the hypothalamus. So yeah, there's a lot going on right here in this little bitty brain part right here. Now, while we are in the brain, I need to introduce you to these two glands. These two glands are part of the endocrine system, but we need to go ahead and we'll just go ahead and learn them right now. Okay, so this gland, the pituitary gland, also known as AKA hypophysis, pituitary gland, is the master endocrine gland. It's sitting right here. And in the back of, behind our thalamus, the pineal gland. The pineal gland. So we will talk about that more in a minute. Okay, and then we have the brain stem right here, which is two parts. This big fat pons and the little skinny medulla oblongata. Well, let me tell you about the pons and the medulla oblongata. So the pons has two breathing reflexes, and the medulla oblongata has all the other reflexes. So medulla oblongata is kind of like, well, you're going to have sneezing, coughing, vomiting, hiccuping, and there's these little centers that are reflexes that maintain your breathing rate and your heart rate. So it's like the inspiratory center, expiratory center for inspiration, expiration. That is just reflexes. You're not like thinking about it. It's just like happening. And then your heart rate. So there's a cardio accelerator and a cardio inhibitory center that you'll speed up or decrease the heart rate. And it is like a reflex. So the medulla oblongata is the reflexes that kind of like keep you alive, gagging, swallowing, all those things. If you were to be like brain dead and the cerebrum was no longer working, like there's no brain waves coming from all of your cerebrum, but the medulla oblongata were to remain intact, you're brain dead, but your body still has the ability to swallow, cough, sneeze, all those things. But even though you're brain dead, it's because the medulla oblongata is responsible for that. Okay, so back to those glands. So this is the gland. It is hanging down here like in front. So on this, the model that has had the sagittal section, you open it up, the pituitary gland would be hanging right here and here. But what was the name of the gland in the back? What was the name of this gland? K. Right here. Well, that is like posterior, and that is going to be the pineal gland. The pineal gland is responsible for your circadian rhythm. Your circadian rhythm is your sleep-wake cycle, or anything that has to do with kind of like light-dark cycles, and your biorhythms. So it's responsible for like knowing, or when you're sleepy at night and when to wake up. You know how you wake up like 5 minutes before your alarm clock, and then you wake up every day at 8 o'clock, and so you wait, and so now it causes you to wake up at 7:55. But then after a week or two, then you start waking up at 7:50, and then you start waking up at 7:45. You're like, it just keeps getting earlier and earlier and earlier. That is the pineal gland. That is your circadian rhythm. Okay, it does that to you. It has two hormones, serotonin and melatonin. And serotonin is released from, these are the two hormones that come from the pineal gland. And the serotonin is the one that wakes you up. It's the one that wakes you up just before your alarm. Like you wake up. You're like, what? And then before the alarm goes up. Now, serotonin is also a feel-good hormone. So if you do release the serotonin to wake you up, it makes you feel good. So like some people, they wake up in the morning and they're all happy, like, oh, and they go get their coffee and they're like all happy, singing. But if you do not have this regular sleep-wake cycle and you do not wake up with serotonin, well, then that's like, you know, waking up on the wrong side of the bed and you're all grumpy and because you did not get a nice healthy dose of serotonin. Melatonin is the one that makes you sleepy, and it tells you like it's time to go night-night. Like, oh, I'm so tired and I'm so sleepy, I want to go to bed. It's bedtime. So the pineal gland is responsible for those rhythms. Now, let me tell you something else. Serotonin, melatonin, not only are they hormones, but they're also neurotransmitters. And the difference between them is that a hormone is going to be a chemical that is released into the blood, while the neurotransmitter is chemical release from the axon terminal, and it goes to a little gap junction to its target tissue. So neurotransmitter does not go into your blood, but the hormones do. And then what else I want to point out on this model, this is, I call this my brainstem model. So this right here is the brainstem. This is the pons, fat pons, and the skinny medulla oblongata. And then over here we can see the thalamus here and here, and then this is the hypothalamus. Below the thalamus, the hypothalamus. So hypothalamus here and here, and then there's the pituitary is supposed to be hanging here, which this is the pituitary gland or hypophysis. And then the gland in the back, which is the pineal gland. So let's review those before moving on. The glands K and X. The brain parts, give the name of the brain part, Y, D. This entire structure, S. And then the brain part A and B. Okay, also 2 nerves. I just want you to know the name of 2 nerves. That's it. So they are really named kind of like according to where they're located. So this one's right alongside your ulna, the ulnar nerve. It runs all along here. And if you kind of like hit your elbow just wrong, it sends this funny sensation all the way through to your pinky, and you're like, ew. It's not funny. It's like kind of uncomfortable. It feels terrible. But that's what they call the funny bone, is when you kind of accidentally hit the ulnar nerve just wrong. And then the sciatic nerve, we already mentioned that it is the largest nerve in the body, here in the gluteal region. We do not want to accidentally hit that when we're performing a dorsal gluteal injection, intramuscular injection. So what is the name of the nerve? Just 2 nerves, okay? What is the name of the nerve A? What is the name of the nerve K? For this one, all I want you to know is the name of the model. Now, it has a super long name. Now, we're kind of like reviewing the different sections. Which one is this? So the spinal cord has been cut so that we're actually looking at the inferior. It's been cut and separated the spinal cord to superior and inferior parts. What type of section is that? So there's a transverse cross section of the spinal cord within a cervical vertebra. So this is the spinal cord here, and then this is the cervical vertebra. So for now, for this first test, all we need to know is the name of the model. So if you see this picture of this model, I was like, what's the name of this? You need to say it is a transverse cross section of the spinal cord within a cervical vertebra. Not too much to ask. And also what I'd like to introduce to you on this very first test, for the first time that you hear it, is the difference between the CNS and the PNS. So you have the central nervous system, that refers to the brain and the spinal cord. The brain and spinal cord. But then there's also the peripheral nervous system, that is everything else. Everything else. So coming off of the brain, there are 12 pairs of cranial nerves that they exit the brain, the cranium. They exit the brain, they go to the eyes, they go to the ears, go to your tongue. You know, there's these 12 pairs of cranial nerves. And then coming off of the spinal cord, there's 31 pairs of spinal nerves that exit from the spinal cord, and they travel all throughout the body. And then there's also some ganglia that are outside of the brain and the spinal cord. They're kind of outside of that, so that's peripheral, out to the periphery. What is a ganglia? It is a collection of somas. So I do want you to know, what is the difference between the CNS and the PNS? Okay, this is, I don't know how many slides, there's 4 slides, and they are for you to review. Okay, so you pause the video and you identify the structures, just until you can name them without looking at your paper, without looking at them, for practice.